Hello everyone, my name is Orhan. I'm a last JD PhD candidate at the University of Bologna. Today I will share my current research findings with you on governing algorithms in big data era for balancing new digital rights, and specifically the role of right to explanation and explainable AI for explainability of AI systems. The main objective of this research is to discover ideal methods to govern big data algorithms and to design explainable AI systems to balance new digital rights. To achieve this grand goal, we aim to understand the need to balance new digital rights against technological advancements and privacy-preserving technologies' contribution toward this goal. We also aim to understand the state of the art in explainable artificial intelligence and to demonstrate the significance of explainable AI methods and right to explanation to achieve true explainability. In this research, I follow a top-down approach. Initially, I conducted general research on today's big data and data processing challenges. By conducting literature review, positive law analysis, and technical testing, I identified the new developments in the field, specifically the 10 big data challenges we face today. In addition to that, we also discovered the ethical principles associated with them and the legal and technical responses to these challenges. In the second part, I narrow my focus down to the explainability of AI systems, explainable AI methods, and the right to explanation. Since this is an interdisciplinary study, it is important to define the relationship among the stakeholders in legal, ethical, and technical communities. This necessity helps clarify the mediating role of lawmaking between the business and technical community and ethicists and privacy advocates. While the business and technical communities want to generate more innovation and wealth, ethics and privacy activists aim to maintain a more humane environment where fundamental rights and freedoms are protected. Thus, lawmakers are required to create a legal environment where ethical principles are protected and innovation and wealth creation are maintained. In comparative law, we clearly see that countries are positioned differently based on their priorities. However, the global community, in any case, does and should maintain a healthy mix of these two to refrain from a global AI dystopia. Although it is important to understand the global AI regulatory framework, this research mainly focuses on European Union's legal framework. In the 21st century, the fields of data processing, big data, and artificial intelligence are inseparable parts of a data lifecycle where data is initially processed by data processing systems, then it is usually fed into a big data pipeline. Then it is usually used to provide a general service or to train an AI model for automated or value-added services. In this lifecycle, each stakeholder has a corresponding legal role pursuant to GDPR. The users of a big data system would be the data subjects. Their data would be processed by the data processors and used by the controllers. Data protection officers would be the person in charge of communication with the data subjects and responsible for the data security issues. Finally, the third parties and recipients are the external stakeholders that receive personal data in particular situations. GDPR requires data processors and controllers to implement technical and organizational measures to safeguard the personal data they process and control. Apart from the general articles such as Article 5, 35, and 25, Article 32 acts as the main article regulating the issues related to security of processing. Additionally, we have more specific measures regulated under specific articles. The main purpose of these organizational and technical measures is to create a data ecosystem of future designed with the main principles of information ethics regarded highly. The field of information ethics is relatively new, and there are dozens of proposed ethics frameworks in their infancy. For the sake of simplicity, we take the trustworthy AI principles into account in this research. The 7 principles proposed by the European Commission's high-level expert group are diversity, non-discrimination and fairness, transparency, accountability, human agency and oversight, technical robustness and safety, privacy and data governance, and finally, societal and environmental well-being. However, protecting these ethical principles is not an easy task. Numerous EU-backed projects led by well-known researchers and our scientists are working on solutions to create a trustworthy environment. In this quest, they identify 10 challenges that may potentially block the pathway to this goal. the contradiction between big data innovation and data protection, several societal and ethical implications of big data technologies, achieving secure and trusted personal data sharing, processing sensitive data, achieving irreversible anonymization and pseudonymization, and other identified challenges are waiting to be tackled to create a more secure data ecosystem in an ever-growing industry. When we analyze these remedies they offer to these challenges, we see a range of privacy-preserving technologies and organizational measures. While explainable AI, secure multi-party computation, self-sovereign identity management, and homomorphic encryption are examples of privacy-preserving technologies, data governance, ethical and technical standards, and integration efforts are examples of organizational measures. When we analyze the frequency of the coverage of these challenges and the measures to remedy them, we end up with interesting insights. In terms of general patterns, we can see that one of the most preferred solutions for data protection challenges is the integration of existing methods. Approximately half of the projects aim to combine different privacy-preserving technology solutions and offer easy-to-use data privacy solutions to businesses in a particular industry. Some of the promising privacy-preserving technologies such as explainable AI, sticky policies, and differential privacy are rarely covered under the selected projects. The project's general theme shows a shift from an enterprise-centric data processing approach to a user-centric data processing approach. With regards to explainable AI, we can conclude that the number of Horizon projects relevant to explainable AI is very low. Less than 20 projects ever mention explainable AI, and most of them do not focus on the ethical and societal implications of AI systems. There is only one project that mainly focuses on explainable AI and right to explanation. Lack of research in this field, despite its relative significance, makes it an ideal field with opportunities for data privacy researchers. At this point, we can narrow our focus down to explainable AI and the right to explanation and their significance in realization of trustworthy AI. Explainability is an important property of AI systems that protects and nourishes a number of trustworthy AI principles. Legal and technical domains develop their own concepts around explainability of automated decision systems. The right to explanation can be defined as a right to information about individual decisions made by algorithms and more. The main articles regulating the right to explanation can be found in GDPR. Although fundamental rights and freedoms may create a right to explanation in specific cases, the GDPR Articles 13 to 15, 22, and Recital 71 are the main sources of the right to explanation. On the other hand, explainable AI is a subfield of AI aims to develop AI systems that we can explain its decisions and process, its strengths and weaknesses, its future behavior. It aims to achieve explainability in pre-modeling, post-modeling, and modeling stages. Before getting into more details on explainable AI, it is important to uncover the relationship between right to explanation and explainability principle. Different articles of GDPR expand the scope of the right to explanation. Pursuant to Article 13 to 15, data subjects have a right to receive meaningful information about the logic involved in case of automated personal data processing. But how should this meaningful information be? Can providing raw explanation data be enough? Not really. AI high-level expert group requires trustworthy AI systems to be accessible, to have a universal design, and to have an emphasis on user centricity. Additionally, the explanation should be in line with the healthy mix of 6 schools of thoughts on what the explanation should be. In summary, an explanation should be understandable by the user, it should be context-specific, and adaptable depending on the user. The right to explanation should be regarded as an umbrella of smaller rights. GDPR requires a set of safeguards to ensure the protection of the right to explanation. While Article 13 to 15 regulates the right to obtain information about automated decisions, Article 22 and 71 regulates the right to contest or challenge the automated decision. Article 22 also contains safeguards such as right to express one's point of view and right to obtain human intervention. Finally, Recital 71 also requires most argued part of the right to explanation, the right to obtain an explanation of the decision after the assessment. When we cross-reference these safeguards' contribution to trustworthy AI principles, we end up with this GDPR framework for this right to explanation. These safeguards are usually triggered from left to the right chronologically. Throughout this journey, safeguards contribute significantly to transparency, accountability, human agency, and oversight principles directly. By doing so, they also strengthen diversity, non-discrimination, and fairness principles significantly. On the other hand, explainable AI is the technical community's collective answer for achieving explainability of AI systems. Although explainability is an issue to be addressed at each stage of AI development lifecycle, the main problem arises from the black box nature of complex algorithms. In an AI system, developers benchmark several machine learning algorithms to create the best performing model, and the main metric they look at is accuracy. However, the algorithms with highest accuracy performance are usually the most complex ones, and they are usually the least explainable ones. Therefore, there is a negative relationship between the accuracy and explainability of algorithm. An explainable AI tries to solve this problem by developing novel transparent algorithms and also model agnostic explanation techniques to open black box nature of complex algorithms. However, modeling is not the only stage of AI development lifecycle that we can strengthen the overall explainability of the model. At the pre-modeling stage, by conducting dataset and feature level analysis and standardization, we can increase the explainability. Additionally, during development stage, we can use explainability as a parameter during benchmark analysis of the rival algorithms. We can utilize a user interface to properly communicate explanations with the user in a format that they can understand. Finally, in overall management of AI ecosystem, we can adopt explainability audit mechanisms, encourage collaborative R&D efforts, and cooperatively develop AI regulations. Therefore, we can generate information on the pre-modeling, modeling, and development process. Instead of presenting this plain and explainable information, we can adopt a presentation logic to achieve the trustworthiness of AI system and present a meaningful explanation in an understandable manner. Therefore, with the tools provided by Explainable AI, we aim to create understandable, content-specific, and adaptable explanations, not just plain information. Pursuant to GDPR's Right to Explanation framework, these explanations should contain a different set of information for each use case. In addition to automated explanations, GDPR also requires human involvement in different stages and different levels. Therefore, AI system architectures ensure a design that takes pre-modeling, post-modeling, and management level explainability into account in addition to model explainability. Thank you very much for your time.